let's talk about a triangle. The number of sides. Well, how many sides does a triangle have? How many diagonals can you draw from a triangle? Do you know what a diagonal is? A diagonal is basically a segment that connects two non-consecutive vertices.
So 0.
Some of the interior angles of a triangle are what?
180.
That we should know. Quadrilateral, how many sides does it have?
4.
How many diagonals can you draw?
0.
Okay. If you drew, I'm going to draw a quadrilateral. That would be 1, wouldn't it? Is there another way I could connect two non-consecutive ones? 2. So there's what?
2.
See, when you have a triangle, that one already connects. All of them are, there are no non-consecutive vertices, are there? These are all things we have learned. How many sides does a pentagon have?
5.
How many diagonals can you draw? Well, let's look. 1, 2. Are there any more? 3, 4. Any others? That's it, isn't it? 4. Now, however, do you know this one off the top of your head? There's a formula. That represents n is equal to the number of sides. So, to find this one, what's my n here? What's my number of sides?
5.
So it'd be 5 minus 2, all of that times what?
180.
What do you get when you put that into your calculator?
540.
540?
Yeah.
Hexagon. Number of sides.
6.
Now, let's start. Let's make this a little bigger. We'll use up 2 spaces for this one. To figure out the diagonals, just go 1 from each one. Let's see. I can draw 1, 2, 3, right? From this one, I've already drawn that one, right?
Yeah.
So there's 4, 5. From this one, I haven't drawn this one. 6, drawn that one. 7. That's right, isn't it? Sometimes it helps to make it even a little bigger.
Wait,
You want to check yourself?
Did you do one from bottom right corner
1.
to top left?
Well, that's why I made it bigger. 2, 3, 4, 5, 6. Done that one. 7, 8. Wait a second. 1, 2, 3. 1, 2, 3. Already did that one. 7, 8. That's 8 then, right? And then did I do what? There's 1, 2 from here. That one left there is what? 9. So how many are there? Have you got 3 coming from each one? You've got 3 coming from each one, you're right. thing about it is you have to define which ones you use twice, right? It's a little hard to count them, doesn't it?
Let's see.
How about here?
720.
How would I get it?
6 minus 2.
And you get 720 when you put that into your calculator?
Yeah.
Not too terrible, is that?
We didn't have to draw that, did we?
No.
Okay.
Okay? Main thing is remember that n minus 2 times what? Is the sum. Another thing I want to talk about is a thing called regular polygons.
Bless you.
You guys know what those are? Those are the polygons you probably see the most throughout the world. In other words, when you see an octagon, can anybody tell me an octagon you guys see all the time?
Stop sign.
Stop sign. Guess what? That octagon is a regular octagon. What makes it regular is that all the sides are congruent and all the what? Interior what?
Angles.
Angles are what?
Congruent.
You know, it's shaped symmetrically, right? How about a yield sign? What is that?
Triangle.
What do you think it is? An equilateral triangle, isn't it?
Yes.
What's the most common quadrilateral used?
Square.
Square.
Oh, we
Guess
don't
what? That's a regular quadrilateral because all the sides are congruent and all the angles are congruent. The pentagon. What do you think of? You think of the one in Washington, right? Well, if you look at that from on top, guess what? It's a regular
Or still
pentagon. Okay, you know that the view from like a helicopter or something like that. Okay, so most of the polygons you're used to seeing throughout the world, you know, different sided ones are regular, meaning that all the angles are the same. To find the interior angle of a regular polygon, you use this. N minus 2 times 180. Isn't that the sum of all the interior angles, all of them added together? Isn't that what we think about it? Then if you divide it by the number of vertices, which is n, wouldn't that tell you what each angle is going to be? I mean, put 3 in there. 3 minus 2 is what? 1 times 180 is what? 180 divided by 3 is what? And isn't that an equilateral triangle? Aren't all the angles 60? Put a quadrilateral in there. 4 minus 2 is what? Times 180 is? Divided by 4 is what? Isn't that what all the angles of a square are?
Yes.
This only works for when they are what, though?
Regular.
Regular polygons. I can draw a 6-sided figure. That's a 6-sided figure right there. Well, it has to be convex. So, okay, I did that one wrong. I think it's pretty obvious that's not regular, is it? So in this one, I couldn't use that, could I? All I know is that all the angles in that hexagon add to what? 720. Okay? It's not so bad, is it? We're going to do numbers 3 through 18, write problems, draw figures, show all steps of work.